Okay, so here's a quick video just to show how we can install Wistar, the latest version from scratch on a brand new server. So we're going to go from essentially nothing all the way up to having Wistar installed, and then we'll load the latest DMX 17.3, and then we'll build a topology, and we'll see how that goes. So it's a brand new server I have here. The first thing that we need to do is just install some basic pre-requirements. So we'll do apt-get install. So the first thing we need is Python pip and get. So we'll get those two things. So it'll take just a minute to download and install.
Okay, so we have Python pip installed and also get installed. And I also forgot to hit record before I installed Ansible, but that is just pip install Ansible. So we'll run that again just so you can see the output. That's just going to make sure we have the latest and greatest Ansible set up. Once that's done, now we can clone our Git repository. So let's go to github.com /juniper /wistar. We can then click on the clone or download button. Copy this link. I have a new window set up, same server. Just in the home directory is fine. We'll say git clone. And we'll clone into Wistar. Okay, so here is the code for Wistar, including the installation playbooks, which is in the extras directory. For this video, I want to install the develop version. So we'll just say git checkout develop, cd into our extras directory. And because I want to install develop, I'm going to actually edit this installation playbook. So generally you don't have to do this. You can just leave this as master, which would be the latest stable release. But for this particular server, there's some features in develop that I want to install that may not be quite stable yet, but for the most part, just leave that at master. Okay, so now we're all set up. So we just call Ansible playbook install Wistar Ubuntu 16, and we'll let this run, and we'll come back. Okay, so our playbook is done. So that means everything is installed and we're good to go. So let's just take a quick look around. So by default, everything is installed into the opt Wistar directory. So we'll just go take a look. We have media, seeds, user images, and Wistar master. So Wistar master is the where the actual application lives. User images is where we're actually going to copy images for things like VMX or Ubuntu or some other. We have seeds and media, which is used for cloud init. And media is if you want to attach like ISO files, to images to like install from scratch or something. So first thing we need to do is let's just go check out the repository. Let's make sure the app is actually up. So this guy's IP address is 1086.925. So by default, we're going to listen on port 8080. Okay, so we have Wistar. So we have topologies, manage hypervisor, images, and templates. So the first thing we need to do is upload some images. So we'll do that. However, actually, what we want to do absolutely first is configure our environment. So I almost always forget this until it's too late. So if we cd into the Wistar master directory, inside Wistar there's this configuration.py file. And what you'll see here is a couple of convenience options. So SSH user and SSH key. These things will get loaded via Cloud Init every time you boot or deploy a new Cloud Init enabled image. So for this, I have we will sudo vi this config file. So for this server, I'll just use the Ubuntu user for now. And then I'll need my SSH key. So cat tilde SSH. Okay, I don't have a key yet, so let's just go ahead and make one using the SSH keygen command -b 2048. Defaults are fine. And we'll just cat the .pub file. So that is cat tilde.ssh id under rsa.pub. Once we have that, now we can edit our config file. Put them in there. That looks good. Okay, so now every time we boot up a new VMX, we should be able to just log in with key-based authentication. So this is really nice. It makes everything essentially Ansible ready right off the bat. So as soon as something loads up, we can just point a playbook at it and go, which is good. So now that we've modified that, let's just restart Apache. Sudo make me a sandwich. Looks like I need to add a host name for this guy. Get these annoying messages out of the way. Okay, so now we need to upload images. So the first thing that we'll do is let's go download a VMX. So I already have one downloaded here just because it's a 3.5 gig file or something like that. Yeah, 3.5 gig. But for you to download this, we just need to go to juniper.net, go to support, downloads, Junos. Now we want VMX. So we can also do virtual SRX, virtual QFX, virtual route reflector, different versions of VMX, Juno Space, Contrail, any type of Linux version. So there's plenty of things that we can download and load in Wistar. So once we're here, click on software. Then we want to grab the KVM version. Just the latest is fine. So 17.3 R1 currently the latest. So we'll just click here on KVM. Now you'll need your Juniper account login information. If you need one of these, I think there's a URL. I'll find it and post it. So we'll agree to the click-through license. And now we can copy this link. This is a pretty nice new feature we have. So we can copy this link. So basically what we would do is say wget, quote this, paste it, -out, and you would do this. And that would start to download the file. So that'll take a couple minutes, but I've already got that downloaded, so we can just go ahead and kill this. And we'll go back to the home directory where this is. So what we need to do is just explode this guy. So it's a zipped tar file. So we'll do tar zxvf vmx bundle. And this will take a couple seconds, so we'll just hold on. Okay, so now that that is done being exploded, we can just take a look. We now have a VMX directory here. So inside here we have a couple directories, but the only one that we care about for Wistar purposes is the images directory. So inside here we're going to grab two images that we need to make VMX sort of run. The first is going to be this Junos VMX x86 64 17.3R1.10 QCal2 image. So we're going to copy this guy. We want to copy him. QCal to opt Wistar user images. Okay, I'll probably have to sudo that. And next we need the virtual FPC. So we'll copy his name. So we'll copy this guy to opt Wistar user images. Okay, so let's just verify that we've got those. So cd into opt Wistar user images, and there we go. Cool. So let's copy this file name again. And now let's go to the Wistar UI, and we'll go to images, define local image. So we have a couple options here. We can just upload an image. So this would be useful for when you have an image on your laptop, on your desktop. You can just say upload image, and then this is just a normal form where you could browse locally for your file, and this will upload this over HTTP. So this works, for the most part, but for big files that are like 3.5 gig, especially when you're working with remote servers. So in this case, my servers are in California. I am on the East Coast, so that would just take forever to download it all the way here and then push it all the way back. So just download it directly to the server, and then we can just define it locally. So we'll say define local image, and this will just take a local path on the server itself. So we'll just paste in the full path here, which again, opt Wistar user images, and then whatever the file name is. Let's give it a name. So we'll say 17.3R1.10. And the image type is always very important. So in this case, just Junos VMX RE is exactly what we want. That's fine. We'll hit submit. this will actually just make sure that the file looks good and then add it to our database. So now we'll do the same for the FPC. So again, hover over images, click on define local image. Let's copy the file name. Paste them here. VFPC 2017-08-10. Description doesn't really matter. Image type, super important. So we have lots of options here, but for the most part, you just want Genus VMX VFPC for your VFPC, imaginatively enough. So we'll click there. So some other options we've got here, so like QFX, Virtual Route Reflector, SRX, Ubuntu 16, generic Linux, blank, Genospace, just some other things. But this is all we need for VMX. So we'll hit submit. And that's all we need. So now we are ready to build a topology. So to build a topology, we just hover over topologies and click on create. And from here, we have a couple options, but what we'll do is say add VM. And let's give it a name. So we'll call this guy VMX01. Choose our image. We'll choose our VMX RE image. And then that'll give us a couple more options here. So we can tell it what our machine properties should be. So how many virtual CPU, how much RAM to give it. And if it requires a virtual PFE, we can select it here. So the defaults are generally fine. So one of the things Wistar does for you is it abstracts all that away. So for Genospace, for example, has pretty beefy requirements. So that's baked into the image type. So when you select an image of type Genospace, it'll set all of these values for you appropriately. So you can still tweak them if you need, but for the most part, this is good. We can also override the default authentication here. So root and clouds123. So this is also configurable in our configuration.py file, but we'll just leave it like this for now. So let's say add and close. So we'll just do 2 VMXs and drag and drop some connections here. And I'm going to make 2 connections between these guys. So we can route these. So you can do some funky routing if you want to make nice, pretty images or whatever. But I just leave them pretty bland. So let's save this topology. We'll call this VMX test. Blah blah blah. And now we're ready to deploy. So by default, we use KVM as the backend. So once we click deploy, that's going to go through and actually build all the domain configuration templates, bridge configuration templates. It'll build the bridges inside OVS, connect all the ports, and then we should be just ready to do some network engineering stuff. So before I click deploy, I'm going to come over here and I'm just going to watch the Wistar log file. So var log wistar.log. This is a good place just to watch in case something happens. So let's click this guy. And now we can see essentially what's happening here. So first we're going to define all the networks, get those all started. Then we will actually build the bridges here, or actually build the domains. So this is, if you're familiar with libvirt, this should be fairly familiar. So this is, how much RAM we need, how much CPU, all the interfaces and what bridges they should be connected to. So you can see some of these guys are virt.io and just normal Linux bridges, and then some between VMs are going to be open vSwitch bridges. So Wistar handles all that complexity for you. So it'll go through, it'll do all that. You typically don't have to look at this at all, just good in case you run into problems. So now we can see that we are deployed and we're ready. So what I'll do now is start up the topology. So we have a button here called Start, and this is just a simple little automation to make your life a little bit easier. So if you have a really, really big topology of like 30 or 40 things, you don't necessarily want to start everything all at once, just because it'll chew up disk I/O pretty bad. So we'll click on this, and this will allow you to set a configurable sleep interval between each one. So for this case, I'll say let's sleep about 45 seconds in between each domain. And then that'll go through and it'll start to start everything for us. So we can come back and watch the log file, and we'll basically see what's happening. So we've made sure all the networks are started, and then we're going to start this domain. And then in a couple minutes, we'll be able to come back, and everything should be up and operational. Alright, so it's been a couple minutes, maybe 5 or 6 minutes or so. So we'll just hop back over into the UI and take a look. So now we see that everything is greened up, everything is running, the domains are running, and also the little boot status indicator dots here, these little green dots indicate that we have actual network connectivity. So now we should be able to just go from the server and log right into these things. So let's go check it out. So by default, we have an implicit management network. Every single VMX or Linux instance or whatever that you attach will always have its FXP0 interface or some management interface connected to our management network, which by default is the KVM Virtual Bridge 0, which is 192.168.122/24 network. So it's unroutable. It's a NATed network, so you have to be on the server to get there. So first of all, we'll go on the server and let's SSH to one of our VMXs. So we'll exit out of here and we'll just say, okay, so you can see no password needed because Cloud Init did its thing. We already have a host name, so our SSH key is there, our username is there, default route information is all there. So we can just say something like show config, and you can see here's our SSH key that we loaded, username. Root password is going to be what we had set earlier, which by default is clouds123. And then finally, FXP0 has been configured with our implicit management network. So that's all good. But what we really care about is, let's say, show chassis hardware. And we see that our FPC is actually online and up, which is good. So we can say show interfaces terse. And we have all our GigE interfaces. So fantastic. So that means he is up, he's functioning, he's available. That's good. Let's check out the other VMX, who is .4. Make sure he's all good. Okay, cool. So this all looks good. So now let's test like LLDP, for example. So we'll log back into this guy, go to configure, and let's say set protocols LLDP interface all. Commit and quit. We'll log into the other guy as well. And commit and quit there. So it may take a minute or two, but we should be able to say something like show LLDP statistics. And let's log into our other window as well. That way we can just be in both at the same time. Aha. Yep, we actually need to configure an interface for LLDP to work. So let's go ahead and actually let's configure LACP while we're at it. So let's say set chassis Took me a second to remember what I needed there. So we'll set this guy as 5.5.5.2/24. Okay, let's just make sure this looks good. So we set chassis, aggregated devices, Ethernet device count 1. Yep, that all looks good. Commit and quit. We'll do the same on the other side. Can't type. And that looks good. Do another commit and quit. And there we go. LLDP is up, which is good. Show interface is AE0. Is up as well. Is he up? Yep. Okay, and now we're pinging across our interface. So there we go. Now we have two VMXs that are up. We have LLDP working, LACP working, because we're using OVS underneath the covers here, so those things just work. So now we can take this a step further and do things like EVPN, VXLAN, so on and so forth. So there you go. Alright, so lastly, more information. So you can go to wistar.readthedocs.io to get the latest and greatest updated documentation. We also have, can't type, wistar.herokuapp.com. So this will be the sign-up page for our Slack channel. So swing by on Slack to ask any questions, get involved in development, etc. And then feel free to open issues or start some discussions on our GitHub repo. Thanks for watching.